packet pushers.
Welcome to Day 2 Cloud, you amazing human you. This is Ned Bellavance, and with me is Kyler Middleton. And today we're going to be talking about database DevOps. And if that scares you, that's okay because it scares us too. But we have a special guest with us to guide us through this idea. It's Adam Furmanek from Matisse Data. He's a developer advocate over there, and he talked a lot about what it means to do databases with DevOps, right, Kyler?
Absolutely. We learned that the database languages that are used all over the world don't have great unit testing. And many times you don't discover that maybe you have made a mistake by changing something minute until it goes and breaks your database and just kills the thing. We also learned that the next big challenge for platform engineering is going to be to help your database vertical to DevOpsify to get there. So that was fascinating. This was such a wonderful talk today.
Absolutely. So enjoy this conversation with Adam from Matisse Data. Adam, welcome to the Day 2 Cloud podcast. We're very excited to have you here. First, why don't you tell the listeners a little bit about yourself? Who are you and what do you do?
Sure thing. Hello, everyone. Thanks for inviting me here. So my name is Adam, and I'm currently working as DevRel at Matisse. Previously, I'm a software engineer for nearly 15 years in the industry, doing quite a lot of stuff around backend, front-end databases, clouds, machine learning, AI, working with startups, with big tech, Microsoft, Amazon, other big companies. Generally been there, done that. And once again, thank you for inviting me, and let's do this show.
Awesome. Well, we're excited to have you on. And you just listed off a whole bunch of different interesting technologies. God, I want to dive into all of those. What would you say your primary focus has been? Or has there been one overriding thing you focused on through all these different roles and technologies?
Actually, yes, there have been. It's I always was kind of close to databases. That's a coincidence, actually, that I am now working in the database space. But I always was close. I was working with banking companies and was doing COBOL, credit calculations, and other stuff with SQL, IBM, ZOS things back then. I was doing ETLs at scale. I was doing machine learning part of cleansing the data for this. So I never actually wanted to be close to that, but it just happened. I have a couple of certificates in various database engines, which I did along the way. And it seems that's something that will stick around. And I'm happy to see what new databases will be there 10 years from now. So generally databases, this is something that is close. Don't know how it happened, but that's the fact.
Gotcha. Man, so a little confession time. Databases scare the heck out of me. I barely understand how they work. When people talk about normal form, third normal form is indistinguishable from magic to me, as far as I'm concerned. Am I wrong? Are databases not scary? Because they seem a little terrifying to me.
Mm-hmm.
That is, actually, I think you hit the nail on that. It's there was this saying, which was in one of the white papers, that claimed that if people knew SQL databases well, they would not invent NoSQL at all and would not, keep inventing different NoSQL databases. Because yes, SQL seems to be quite easy, but yet people do not necessarily feel like they really want to dive in. They don't necessarily understand all those things like normal forms. You mentioned third normal form, right? But it's something 10 different normal forms when you go to Wikipedia. And it's what is this? And when I'm interested in that, right? Generally, databases, well, we all use them. But even though we may say that we kind of know what those beasts are, we understand how to deal with them. We have so many tools, libraries, frameworks, whatever. But pretty often when something breaks, we are oh, snap, I'm not necessarily very happy to understand all of that. And I don't know how to tackle that. So I feel that's prevalent in the industry. So you're not alone here, I'm afraid.
Oh, okay. Feels good.
And Ned, you just used a term that I don't understand. I think you both are ahead of me here. So I want to catch up. What is a normal form in the context of a database? What does that mean?
Let me tell you a story, a little brief of a history around databases. So generally, when it all started, and I think it was 60, 70 years back, we didn't have SQL at all. We had things that was called Codacil group back then. And things were much closer to things we would call today like graph databases. Graph databases were common, and people felt like, yeah, this is how we just put data. Basically, it was completely non-structured at all. And then someone came and figured out, okay, let's have a very simple model for that. That's how SQL emerged. Another little fun fact around here, SQL as we know it today, meaning the SQL query language, was not the only language that was there to query relational databases. There was another competing language, which name I don't recall, but it will be in show notes for this episode. But anyway, now whenever we call this SQL, previously, like 40 years back, it wasn't like that. It was a relational databases and language for querying those. And then things started to work. People got used to that. They didn't even notice that like SQL is completely ill-designed, because nowadays, whenever you do select something from table, your IDE has no idea what to suggest when you just type select, right?
Mhm.
What should I type? I don't even know what the table I'm trying to query. So even the language does not make it easier. And the normal forms, just to answer your question, was that along the way, when we were improving many things, we learned how to avoid pitfalls with SQL databases. Pitfalls like how not to duplicate data in various tables, how to make sure that data is consistent, that we do not run update that would break some records and leave our database in an inconsistent state, inconsistent from a business perspective. So normal form is, there are many of them. Those are like different levels of what guidelines you follow when structuring the data, structuring your tables, columns, schemas in general, to make sure that your database is easy to maintain. So third normal form is kind of the de facto standard, we would say. I mean, those are the guidelines you definitely want to follow in order to avoid most of the pitfalls, but it's definitely not the end of the road. If you really want to do a PhD in that area, it's like I mentioned, 10 different normal forms, and sometimes they are numbered, sometimes they have names like from the name of the inventor. So there is like, I think, Boyce Code normal form and other stuff. So yeah, you can spend quite a lot of time learning about that. But many of those normal forms, especially those first 3 or 4, they are quite intuitive. They just want you to design the data so you do not have duplicates, and it's easy for you to delete the row so that when you delete it once, it's actually is gone and you do not have any remnants around, and that you can basically query the data and you get consistent results between queries. That's the intuitive idea of the normal form.
Totally. When you're saying normal form, I'm hearing best practice. It sounds like that maps pretty well.
That is exactly what we have, right? And fortunately enough, with this best practice, it's more or less enough for us, meaning that you follow this best practice and you are good to go. Unfortunately, when we talk about databases, there are so many things that we follow as best practices and we believe there should be enough, but the reality shows that's not necessarily the case, or maybe there are missing pieces that we should fill in around databases. And that's probably what makes them hard after all at the end of the day.
One of the terms I don't really like is best practices because it's so context specific. What's best practice for you in this very specific scenario might not be best practice for someone else who's in a different regulated industry or is trying to solve for a different problem set. And so people will throw out these general best practices for things. But when you actually take a look at what went into that, it made sense at the time for that particular situation, but now it doesn't make any sense. Like changing your password every 4 weeks or whatever is crazy, but it's still a quote unquote best practice for so many organizations.
I live in Poland now, and according to our legislation here in Poland, since it's so like old days and not updated at all, it requires you to change your password every 30 days. This is like national-wide legally obligation. If you
Huh.
don't do that, you commit a cyber crime. So, better safe than sorry.
Oh, there's so many better ways now. And I'm not going to go on like my security rant because that's the rest of the show if we do that. Maybe let's focus it back on databases. Everywhere that I've ever worked of any size has one or more dedicated database administrators, DBAs. And in my experience, at least, they were a little persnickety. They didn't want anybody touching their databases and their database servers. Whether you were a developer or an infrastructure person, they're like, no, this is my stuff. Stay away. The idea of database DevOps, which is kind of what we're going to be focusing on today, would have them screaming for the hills, like, no way, never in my realm are you doing that. Does that line up with your experience? And how can we ease those concerns a little bit?
I think this is actually good starting point to see why this one DBA protecting and polishing their database is something we just can't cope with anymore. Like 20 years back, we just had one application, monolithical, with one database. Things were easy back then. Obviously, deploying new version was a 2-week work for us. It was taking like crazy long to deploy anything. But generally, when something broke, it was easy. Yeah, it was the application. But now we have what? Hundreds of microservices, hundreds of clusters, multi-tenant applications, deployments going through pipeline like what? Every minute, every hour? Obviously, that depends where you work at. If you are in like fast-paced environment, probably you deploy often and you are not scared of deploying like on Saturday evening or whatever, right? If you work in some, let's call it little bit more established companies that want to protect their data or whatever, you may deploy a little less frequently, right? But still, no matter whether it's a startup or a Fortune 500 company, we need to deploy fast, and we have dozens of applications under our umbrella, even for one single team, right? So the complexity has increased severely in the last years. And now when we take a look at databases particular, it means that we can't just rely on the same processes that worked for us back then 20 years ago. The same way we learned with DevOps. DevOps kind of started like, okay, development and operations are just too slow because of this communication bridge in between. Let's put those two teams together so they can cut on the communication and work faster. And then we learned actually it's a little bit easier if we just, blend those two teams together. And we have DevOps engineers that are doing, both of these sides. Obviously, that's up to the definition of DevOps, and many companies kind of, turned it upside down. We know how it goes. We know the drill, right? But generally, that's the idea. And the same must happen with databases. We can't just rely on this paradigm that we had back then, that when there is something wrong with the database, then what? You just raise a ticket to your beloved DBA, hey, give me logs or tell me what to do. It just doesn't scale. It's just way too slow. Looking at it from this perspective, how we introduce DevOps, how we wanted to blend security into DevOps to make DevSecOps, how people are now, crunching hard the idea of MLOps. We should have database ops, whatever we call it. But, well, it's a natural and logical step. Why don't we have it yet, right? So being that said, we might actually start asking us, okay, why don't we have DBOps? And there are many challenges along the way. And when speaking about challenges, I will also explain what we need to feel in order to have that. So the very first thing I would start with is how we as developers, DevOps engineers, or whatever role we are now, how we test our databases and how we test our applications that talk to databases, right? We know we should test our apps, right? So we have unit tests, integration tests, testing pyramid or whatever else, testing trophy, whatever you follow, right? Whenever we test the interaction with databases, we focus on, hey, have I written the correct data or have I read the correct data? But we do not verify at all, how have I done that? Did I use indexes? Did I use efficient queries? Did I use one query or maybe n+1 queries? Did I use common table expressions for that, right? So there are many things that affect the performance of the database. And there is also many other things that we'll probably speak about later on, like configuration, extensions, etc. But those are just the things that they do affect databases, especially when we go to production, but we don't test them at all. Like nearly not at all. The only thing that we do to kind of verify the performance before deploying to production is running load tests, right? But the load tests, they have like two terrible drawbacks. First drawback is they are expensive, slow, and sometimes hard to maintain. That depends on the application we implement, right? But if our application is stateful, if we need to have correct data distribution, deal with GDPR or California Protection Act or other thingies, If we need to replay a specific traffic, then just building proper load tests and running them reliably so we get meaningful results is non-trivial, right? But the second bigger drawback is they happen far too late in the pipeline. DevOps and generally our software lifecycle is now about efficiency. How can we do things faster, more often, more frequently? And now you run load tests at the very end of your pipeline after you implemented changes, committed them, reviewed them with your friends and teammates, deployed to pre-production. You run load tests for 6 hours, and then you learn, oh snap, it's not fast enough for production. So what do you do then? You start from scratch. That doesn't sound efficient to me at all.
No.
This is the biggest issue with the test. So just wrapping up this particular topic, just like we said with those best practices, which you don't like apparently the term, but like our best practices in the industry is just test the stuff, right? Have tests. But seems like we are missing quite a big chunk of testing how we interact with databases. We're all good with that. That could be one of the reasons we don't have DBOps, and one of the things we need to fill in order to have proper DBOps or proper database guardrails, as we call them sometimes.
We just talked to someone earlier today that was saying that this role, this sort of child of DevOps and database engineering, should be called data engineering. Is that a term you've seen for this type of role? Or should should we start skilling up on our database skill set to help the database team become more DevOpsy and deliver frequently and test and stuff like that? All the DevOpsy stuff we've learned for testing and delivering applications. That was a very vague question that's big, but what do you think?
Obviously, we could tell developers, hey, from now on, you need to own databases. You just, take care of that, go deal with it, right? But, well, they are swamped. They are not doing that, not because they don't like to, but that's because, well, they have plenty other things to do, right? So in my opinion, what needs to happen is we need to shift this ownership of databases onto developers. They need to own it, just like they own infrastructure with IAC, right? Just like they own configurations with GitOps. They need to own databases the same way. But it's not just that we push this ownership on them. It's also we need to change the way how we reason about databases. And just like we improved our deployments by building so many tools and processes, right? So many tools for automated deployments, for canary deployments, for monitoring metrics, rollbacks, etc. The same way, we need to build tools and processes for databases that let developers own them. What I mean by these tools and processes is things about, for instance, testing the stuff before deploying to production. We need to have tools and database guardrails that will protect us from deploying code that doesn't scale, deploying code that, runs n+1 queries instead of just one query, or things that verify whether our queries use indexes and whether we don't break those indexes accidentally 6 months from now. We need to have those tools that will do this due diligence, kind of like database review. Just like we have code review now, we need to have tools and processes for database review the same way. And similarly, once we deploy to production, and I'm brave enough to say, we really need to get good observability, not the monitoring that we have today. Our today's monitoring is completely wrong. Why? Because it mostly shows us, it swamps us with raw data and raw metrics, but no reasoning at all. It shows us, yes, your CPU spiked. This is your memory usage. This is how many files you have. But how do I know why is my CPU load going up? How do I know whether it's due to database updates or whatever else? It's not about monitoring swamp me with all you have. Fire all your guns at me, I will do the reasoning. No, it's about, okay, you have this data, now you tell me what is wrong. And this is what we need to have. We need to have tools that can do this reasoning and be very database focused, database oriented, and can connect the dots. This is your CPU spikes because your query stopped using index, because you deployed something the day before yesterday, and now you have different data distribution, and so you are not using searchable query, and that's why you are not using index. And the solution, because, well, the most important part is the solution is
Right.
just run this create index and that's gonna work for you. Just approve this like automated pull request I created for you. So if we have those things, then we can move everything to developers, because it's not like we add them work. No, we sort of give them tools that replace some of them their work and optimize it. And this is very similar to how we did with the deployments. Now we can deploy hundreds times like a week or a month because it's automated. The same way with databases.
There is so much to unpack there. I'm going to try to start a little bit back. What does it mean for a developer to own the database? You said they need to own the database, but what does that ownership actually entail, and where does it end for them?
The ownership, the way I would define it, is whenever you have an issue, you can fix this issue end to end on your own and independently. So you don't need to speak with a separate team of DBAs to get database logs. You don't need to, raise a ticket to someone else to review the metrics or understand what happened in the database, or maybe what is the configuration of the database. Sometimes it's because, communication between teams is slow. We know cutting communication is killer feature, so we really want to have that. But sometimes it's also because there are so many things happening in the database that, there is a separate team that handles all of that because it's just too big of a task, to put it on developers. But it slows us down. So to own the database is to be able to troubleshoot and fix and basically maintain or provide like full database reliability independently within the development team. Just like with the, let's say, deployments now. Developers don't need to raise tickets to, get another EC2 instance, typically.
Right.
They just have IAC. They don't need to ask anyone, hey, create a feature branch for me, or please run this feature branch through automated test suite, right? They own it. They deploy it end to end till the very end. And when something goes wrong, they can access logs, metrics, etc. Same should happen with the database. That's what I would call a true ownership.
We're pausing the conversation for a brief reminder that Packet Pushers has a Slack community, and you can join for free. Whether you want to ask questions, share tech tips, swap stories, or just connect with other engineers, the Slack community is a friendly, collegial space. Check it out at packetpushers.net/Slack. That's packetpushers.net/Slack. And now back to the show.
For DevOps, I used to feel the exact same way as you described database stuff. Is I'm just absolutely terrified of it because I can't write a whole Ruby on Rails or .NET app or anything like that. But I do know enough as a DevOps engineer to run the tests and deploy it. So as a database helper, as a DevOps engineer helping the database team DevOpsify their processes, what do I need to know? What should I learn to connect to them and help them get there?
Well, we need to focus on generally things that can break often. So let's see what the biggest or the most common challenges or issues around databases can be. So first thing is we may deploy bad code to production. Bad as in the code that has no ability to scale. It's just simply, that's not going to work. That can be because we have inefficient ORM configuration that is sending queries like in lazily fashion instead of, eagerly taking the data. So we have N+1 queries problem. We may be running queries that are inefficient because we use, for instance, common table expressions. And common table expression, it improves readability, but at the same time, it can break your performance, like double the execution time. Or we can be just writing inefficient queries. But when I say writing, I don't mean writing by hand, because most of the times it's our libraries generating that, right? So it is that we do not necessarily know what has been generated by that such a library, right? We don't know what queries are actually going to the database. So the very first thing is, in order to prevent the bad code from reaching production, is we need to actually see this code. We need to see what's going on in there. We need to have tools. And imagine like that. You have linters nowadays. Those linters can do code formatting for you, or can suggest you are writing the code like it can be written better, right?
Mm-hmm.
Or anything like that. why don't we have database linters? Why don't we
Hmm.
have a tool that is telling me your ORM is running n+1 queries instead of one? Take a look, maybe that's an issue for you, right? Or you are reading this table and you are doing a table scan. Table scan meaning you read every single row from the table instead of just using an index to pick only the rows you're interested in. Why don't we have tools like that? And just to provide answers, it is easy to build such a tools. It's just we haven't yet spent enough time to build those tools, because in order to get them, it's as simple as we have open telemetry nowadays. We have generally monitoring, observability around that stuff. Let's just take open telemetry, get the execution plan of a query. So whenever our application sends a query to the database, we grab this query, we run explain this query, and database is telling us exactly the execution plan, how it's going to be executed. That is also surprising to many developers. They don't even know they can do something like that, right? One of the things whenever I debug something, I always want to have tools that really show me what's going on behind the scenes, right? That's debugger, that's decompiler, that is like a Wireshark or any network sniffer or proxy, right? I just want to see that. For databases, there are ways to do that, but often developers either do not know they even exist, or they just don't have them configured or didn't use them in their environment. That's the first thing. So whenever we say that we would like to have this DBOps to help in databases or whatever we call it, now, first thing is, well, you need to see what you are trying to help with. See the queries, see the configurations, see the indexes. But it's just the middle of this road. The other part is whenever things change or whenever things flow through our pipelines, we need to be able to tell in advance how it's going to behave in production and how things we do in production may affect what's already there. For instance, you as a developer, you did your due diligence, you implemented a query, added an index to make the query fast, which is cool. But 6 months from now, someone else steps in, they slightly change your query, and from now on, the query doesn't use the index anymore. Is anything going to turn red when you deploy things? No, everything's going to be green in our pipeline. Is everything's going to die in the database once you deploy to production? Sure thing it is. So this is what we need to have. We need to have this other side of monitoring that is telling us, okay, this change is dangerous. Don't deploy. And if it happened just because we made a mistake or we didn't catch it, this thing needs to tell us, okay, it's not just that this query is slow and it wasn't slow a week ago. Not like that. It must tell us, hey, this index is not being used anymore. Maybe you updated extension. Maybe you changed configuration. Maybe you changed connection pooling. Maybe you scaled your database differently. Maybe you changed partitioning. Maybe now your query reads all the historical partitions instead of just one you are interested in, right? Those are the things that immediately explain what is wrong with the database, but we just don't see them. And this is this other side. First was prevent the bad code from reaching production, but the other side is, okay, have tooling that shows you what is actually happening in a database in the database-oriented fashion, not like CPU spiked.
Let me ask you a question. So, a lot of what you're saying reminds me of the issues that application developers have with interacting with the network until you put the right abstractions in front of them. Because a lot of the times I would see really inefficient applications that were making network calls that weren't done in a way that makes sense. They're reaching out to a database or another service that is in a different data center and it's got 100 milliseconds or 200 milliseconds of latency there. So every time it needs to hit that thing, you're adding 200 milliseconds of latency. And it was just that there was no instrumentation or monitoring to give that feedback to the developer. There was no obvious way to test it. And so they didn't know that that was introducing these inefficiencies into the system. And so a lot of what you're saying, the way that we solved that was by slapping an abstraction on top of that that would route the traffic to the closest instance of that service instead of sending it over to that other data center and kind of cutting the developer out of the mix or giving them something that would prevent them from making that mistake. So are you looking more at tools that will stop developers from writing inefficient queries by adding an abstraction? Or is this no, they still write the query, but we're going to kind of give them some tools to figure out why the query shouldn't be written that way?
I don't think you can answer that as an either or. I think it's
Mm,
kind of two-way step, like it's going to be a process. Ideally, our North Star is always to prevent this thing from even happening. Just like you have compiler, if you can make your compiler reject your code when there is no way it's going to work, it's great, right? But
right.
sometimes we just write in languages that like are not compiled, and we just want to have linters or static code analysis or whatever else. I'm not here to bash languages, not nothing like that. But it's not that we need to decide either or. So to answer your question specifically, if we can prevent those issues from happening because we have compiler that makes it impossible to write invalid or inefficient query, yes, go this way. But I'm afraid reality doesn't work like that. And there will be many cases where we do not have ability to block that from ever happening again. And in that case, we will need to have tools that show us, okay, maybe we messed something up, but let's make it at least easy to figure out what did we do wrong, right? And the example you gave is also about the culture. Database guardrails, it's not something that we can do only with the tooling. It's also about how we use the tools and how our organization works. For instance, 25 years ago, Corba was super popular. I don't know whether our listeners would know what Corba is, but generally, if you have RPC or gRPC, nowadays gRPC is the new Corba. Basically,
Okay.
30, 40 years back, people were figuring out, okay, how do we do remote calls between servers? So there are actually two different approaches, like logical approaches, how we can tackle that. They are not much different, but still. One approach is, okay, let's expose the API, kinda, which we call REST endpoint or whatever else. But the other approach was based on, hey, we have object-oriented programming languages. Why do not I just create an object, like new object, but this new object sits actually over there 100 miles from here on a remote server. And why don't I just call object.foo and bang, it calls this foo method on the object that lives very far away from here. And this is Corba. Corba was Common Object Request Broker Access, magical acronym that basically tells you that, hey, you can create new object that lives here locally or very far away, and you don't see the difference. And that was very interesting idea, and people loved it. But then we learned, okay, if we continue writing our code the way we used to, and the way we used to was, we want to have small methods, granular methods, readable code, right? Then we do methods on objects, and each method is going to take this overhead of half a second just by traveling through the globe across the network, right? So now if you call 100 methods instead of just one, then the penalty is enormous. So we learned, okay, first, this shouldn't be just transparent. No, we should be aware when there is a network call, and there should be some big red sign. There is a network call over there.
Right.
Be careful. And second, if you need to do the network call, use some umbrella API so you make just one call and it does all the magic instead of doing 100 methods. Same idea is with the databases. We need to make this shift. It's not like we do what we are doing today and we hope all is going to be perfect and much more efficient and we will have DBOps and whatever. No, we will also need to change the way how we reason about our applications and how we deal with our applications. And you mentioned abstractions. We need to come up with abstractions that from one point will hide the complexity of, for instance, creating SQL queries. And ORMs are quite good at creating those queries, quite good as in they will hammer the query no matter what, right? But at the same time, we need to have abstraction that is telling us what you're doing here is kind of a little bit no. Maybe reconsider if you're doing it. Okay? I can hammer this query. I can do 100 calls over the network. Not a problem at all for me. But that's not the best idea. And generally, those database guardrails, When we are talking much broader about, because we touched upon ownership, we even started with developers may not know what normal form or other stuff are, right? This is exactly the thing. We need to change this mindset. It's first, we need to have those tools that help us. We need to have processes that kind of integrate this database reliability into what we do today. It's not like we rely on DBAs, but we also need to have tools that we have in our pipelines, just like we build DevOps, right? But ultimately, it's also need to be this shift in the whole organization. Databases are not black boxes in the sense that we really don't care what's in there and we have no idea what's there. It's just we know they are complicated beasts, but now we build proper abstractions and we know what we can use them safely so they do not blow up whenever we deal with that. And this is also a big work, not only for DevOps engineers or developers in general, but also for platform engineers, for instance, right? Platform engineers, they kind of need to push this new approach onto the teams, because if you come to developers and tell them, hey, you need to own databases, but you could say, if you own whatever, yada yada, right? They will be like, maybe not, I'll pass, right? But to be kind of pushed on them. We need to, I'm not saying force them, because it's not about, pushing someone hard to do that, but we need to reshape this industry to segue and to shift this ownership towards developers, so that one day we actually, just like with DevOps, we started with bringing teams together, but our ultimate goal was to make it even faster. And now we have DevOps engineers. The same with databases. We may start from how do we help with databases, what tools we build, but ultimately we want the developers to own the databases, and issues never happen at all because we have like compilers that prevent them, right? That's the North Star, but it's going to be a process, not a single step that we can take.
That was so well stated. I don't have a follow-up question. I see Ned waiting for me to talk. That was incredible. I don't even think I disagree with anything that you said there. That was fantastic.
Well, what jumps out at me is that such a key component of this is the feedback loop. Having the necessary observability and monitoring, and being able to take disparate sources of information, the CPU spike like you talked about, and disk IO, and then also the execution plan that's coming out of the database engine, and doing a correlation between them to say, okay, your problem is this ridiculous query that you've put together that has like 26 inner joins in it, and you shouldn't do that. And the only reason that occurs to me is because I dealt with this exact same thing when I was working on a project for a healthcare company. They were adopting an upgrade to this one system, and I had an Oracle DBA with me, and he was doing the analysis of the queries that the application team had written. And he was just like tearing his hair out because of the inefficiency of some of these queries. Like, we're talking a query that was like 300 lines long. And he would just look at it and be like, yeah, there's a reason it doesn't return a result for 30 minutes.
Yeah, exactly. I had similar case in my business applications, like just like ORMs, they are pretty good in hiding this complexity, right? I was optimizing once a query, which was like, I don't know, 10 lines of JavaScript code that was creating this query via ORM. And it cost something like 10 different joins. And the query was bringing 300,000 rows just to return one single entity, right? There is a reason why it doesn't work. The reason is not because databases are slow. The reason is maybe you shouldn't be doing that. But in order to figure out that you are doing something wrong, while it seems easy when we just discussed that, yeah, let's have something, I don't know, static code analysis that is going to tell you this is not going to work. This is actually much more complex, and it spans across the whole life cycle. Just like we have like telemetry. So we can enrich or instrument our libraries and products, applications, so they emit some telemetry data like logs, metrics, whatever. Just like we can build monitoring on top of that, and later like application performance management, right? Ultimately, what we need to do is we need to have the reasoning. And this reasoning needs to be database oriented or focused on the things that can participate in breaking the stuff. Because maybe this, like you mentioned, this 30 minutes long executing query It's not a problem at all if we are running that in a data warehouse overnight and we just want those the following morning, right? Maybe it's not a problem at all. Maybe it's not a problem that we do sequential scan over big table because, well, we can wait. Or maybe it is a problem because we are running in OLTP application, meaning that our transactions, they need to finish in like milliseconds. And the slightest delay is something that we can't, accept. But to answer that, it's not enough just to analyze CPU or disk IO or whatever. It's understanding the whole concept of why we implemented the stuff, why we implemented it the way we did, and whether this is acceptable or not. So this is much bigger observability spanning across the life cycle, starting with the moment we type our code, going through how we deploy it, what we deploy, where we deploy it, and when, until the business decisions, okay, is this acceptable for us or not? And this is like, just like we are now discussing databases in general, this is like much bigger movement in this whole industry. It's not like database ops, it's like business ops, I would call it. We need to really understand each part of the business, how tech integrates with that. And for that, yes, this is reasoning and also tools that can do much more than they do today.
You talked a little bit about reshaping the whole industry to bring like this DevOpsy mindset together with database ops. And I think that's incredible. But it reminds me of when DevOps started to gain prevalence as a movement, and the developers were kind of pushing back against it. Hey, I don't want to learn infrastructure. And the operations team said, I'm not a programmer. Why are you making me do this? Do you think that database engineers will be excited at this chance to learn new skills, or do you think there'll be a pushback? And where do you think that leads us? Is this going to take over in the same way DevOps did?
That is a very good question. Are they going to be excited? Well, I guess I know the answer. They are not. They are not, obviously. But this reminds me back one thing. When I was working with machine learning at Amazon, at Prime Video specifically, many times I was getting questions from business that were completely not like about what I do per se. It wasn't like, okay, I was running ETL and machine learning solutions for recommendation systems, right? But business wasn't asking me, hey, why do we have this result? It was much more like, hey, why do people watch Bob the Builder so much? And this is not like a technical question, right? This is the question like on a business level. And back then, I was kind of predicting when people were asking me, okay, how is machine learning going to evolve over the next years? I was telling them that we need to basically bring machine learning to completely non-technical people. It can't be that me personally, I as a programmer, I am writing a software for video recommendation, for music recommendation or something else, because I have no idea about that. I mean, yes, I can learn sociology. I can learn about how humans behave, what they do after hours, right? But it's a completely different field of science. We need to build tools that let those other scientists reason about trends in videos or whatever. And they need to be able to use machine learning for that, but not is in a way that they tell programmers what to do. No, they just need to be able to take this machine learning and just start using it. The same, I think, needs to kind of happen and will happen when we are now trying to answer how is this movement going to change our industry. Exactly the same way. It's not anymore that we do like database optimization. It's not that we see this database at all in the picture. We need to segue towards this business thinking. Not that I have database. I have my customers that I can reason about or something like that. So this is obviously a very hard to achieve goal. So our North Star that we'll be pursuing probably for decades. But in order to make step towards that, what I think should happen is just like you asked, we need to have this movement that people will be initially hesitant to start. They will not be very happy and will be reluctant to take on more ownership and reason about that, just the same way they weren't happy to maintain infrastructure, right? But we need to bring all of that in order to move faster and in order to achieve more. The most important part in here that scares people the most, in my opinion, is that whenever we tell them you need to own more or you need to do more, they feel like, oh snap, so I'm going to do what I'm doing now and something else. But it's not the case. Just like we build abstractions, we are not programming our CPUs anymore. We are programming something very high level, right? The same way, we are not going to program things in the database the way we do it now. We need to build abstractions so that we can do more by doing less. That's the idea. And even though it sounds a little bit difficult to grasp now, because how am I doing that? What should I do next? We need to basically do those little steps, baby steps, right? We need to start seeing, let's start with that. Answer if you can tell what queries are actually happening in your application and what indexes you have and how they are used, right? This is a very good start to have this observability. And then we can adopt more and more tools and change our mindset to be able to reason much faster and do more without actually working more, because that's what we would like to do.
When you're talking about building tools and helping these sort of highly vertical teams like database engineering do stuff in a more automated way, I'm hearing platform engineering. That discussion's been going on for a while. So is that what's next? Is platform engineering for databases to build those tools and help them get there? Is culture next? Like, how do we get started?
I think platform engineers, they have a big responsibility now ahead of them. They really need to bring those tools, build them, adopt them in their organizations to start this reshaping of the mindset. Because obviously, developers won't be happy to take more. DBAs will not be happy to leave their databases just because, well, they would need to quit at the very end of the day, right? Because all we are talking about here is how do we automate the DBAs, right? So they won't be big fans of this idea. But still, this is why I'm saying this is a big responsibility of platform engineers. They really need to start this movement and push it on many teams around. It's not that DBAs will, be fired and will go like unemployed. No, they will have different things to work on. It's not that we are going to break something or get rid of something. It's just we want to do more at the very end of the day, but work less. So this platform engineering responsibility is to start this movement, to bring actual tools, build this notion of we need this observability, that this database aware, and we need to expect the developers to own their databases end to end. Yes, initially it's gonna be much closer collaboration between developers, DevOps engineers, and DBAs, but sometime in the future, it will be just all those teams, they kind of blended together. And now we expect developers to have database knowledge, but not like we don't expect now programmers to understand how CPUs work, nothing like that. But we expect them to understand programming languages. It's not that we will expect developers to understand, okay, how is B-tree in databases implemented? No. But it is, hey, you need to be able to pick between like vector extension to your database or maybe a completely different database that is tuned for machine learning vector use cases. This is the practical working knowledge we expect. And platform engineers, they need to start this movement today, no matter whether it's startup or Fortune 500 enterprise ahead of them.
Wow. Yeah, it definitely seems like it's going to be a long road, and platform engineering is going to drive a certain portion of this. And just like any other profession in the world of technology, you're expected to upskill over time, and that you can't just do one thing for the rest of your career. It's going to require a constant state of learning. And hopefully, listeners, that's what you're getting from listening to this podcast is now you know a little bit about DevOps for databases, and you can use that basis of knowledge to expand your understanding of databases.
Exactly. I think you put it very well. We need to upscale because, well, the world has evolved and increased in complexity significantly, and it's not getting any easier. Just like one day we will conquer the moon and Mars, and we will have like network calls across planets. It's not gonna be, single node monolithical application anymore. There is no turning back. The same way here. Yes, the easy days are gone. We kind of need to upscale and understand more. and we need to make it as easy and as achievable for us as it's possible. So let's start this movement earlier than later, and let's embark on this journey.
Yeah, let's go on a journey. I think that's a great point to ride out on. Adam, this has been a fascinating conversation. I think I speak for Kyler when I say we're just like, this is a lot of information to process and think about. And I know you're writing extensively about it. If people want to hear more from you, want to read some of these blog posts, where can they go and check it out?
Yeah, so there's going to be a little bit of salesy marketing pitch. As I mentioned, I am working at Metis currently, and all the things that we build over there are around the topics that we discuss. So if you find that interesting, feel free to go to metisdata.io, read the blog posts we write about this movement, database guardrails, about preventing bad code from reaching production and building the observability. Drop us a line. You can find me on the internet easily. You can YouTube me quite easily. So let's stay in touch. I'm also on X, previously Twitter, as Furmanek Adam. And yeah, just take a look at that. Drop me a line if you find it interesting, and let's stay in touch.
Awesome. Adam Furmanek, thank you so much for being a guest today on Day 2 Cloud. We really appreciate it. And hey, listeners, virtual high fives to you for tuning in. If you have suggestions for future shows, we would love to hear them. You can hit either of us up on LinkedIn, me or Kyler, or you can fill out the request form at packetpushers.net/FU. The FU is for follow-up. If you're interested in chatting with us, did you know that we have a Slack group? Yeah, that's true. You don't have to scream into this technology void all alone. You can join the Packet Pushers podcast Slack group. It's open to everyone. Go to packetpushers.net/Slack and join. It's a marketing-free zone for engineers to chat, compare notes, tell war stories, and solve problems together. And there's a dedicated channel just for Day 2 Cloud listeners. So hopefully we will see you there. Until next time, just remember, cloud is what happens while IT is making other plans.